Hello and welcome back, everybody. Today in Algebra 2, we're looking at section 6.9, which talks about how do you solve for exponents using logarithm. Or actually, more like what are some of the properties of exponents? Because in the previous section, we learned how to actually solve for those exponents. So, for example, if I have something like, say, 5 to the x is equal to 7, and I want to solve for x, we basically change that 5 into a base 10, and then afterwards work the algebra in order to get to conclusion. And then after that, we said, okay, well, there's a shorter way of looking at it, because if you look at the very beginning to the very end, the answer comes out to be the following then. X right here is equal to the log of 7 divided by the log of 5. And this is very consistent. So meaning if I have a to the x is equal to b, the answer x is always going to be coming out to be the log of b over the log of a, provided that a and b right here are going to be some sort of positive number, because we can't take the log of negative numbers. So this form over here, where we have the log of a divided by the log of b, since it's so consistent, we actually want to utilize it a little bit more. I'm going to give it a formal definition here. So our definition that we're going to be working with is that the log of b divided by the log of a is equal to the log of base ab. So these two things are exactly identical to each other. So going to our previous example over here, if I have 5 to the x is equal to 7, the answer is supposed to be equal to the log of 7 divided by the log of 5, which now we can rewrite as the log of base 5, 7. The log of base 5, 7. That's how you actually say it. And the reason we're doing this is having to write it as a base 5, like the subscript of 5, that gives us like a better idea as to where the 5 is actually going to. Because if you again cut the middleman of taking the last step right here and the previous and the original step right there, you can see that base 5 is literally the base of the other side, and hence that's why it's called base 5. So here, taking another example, if I have 3 to the x is equal to 2, yes, the answer according to last section is going to be equal to the log of 2 over the log of 3. But now, according to our new definition, we can also say that this is the same as log base 3 of 2. So either one, those are all going to be interchangeable between the three forms. Okay, so let's take this new definition of logarithm and see what we can do with it then. So here are some examples. I want to solve for x in each case with these new base logarithm. So in the first one, we have log base 2 of x is equal to 5. Now, for something like this, we want to be able to work backwards in order to figure out what x is without having to use a calculator. So this, if I were to rewrite it using what we just did, this is the same thing as saying x is equal to 2 is the base on the other side, where 5 is then the exponent then, according to our definition. And that right there, now it's easy to solve for, because 2 to the 5th, we have our answer for that one. So x is equal to 32. For the one on the right, same idea. Log base 5 of x minus 1 is equal to 2. So that means that x minus 1 is equal to 5 squared. This 5 goes to the other side as a base. The 2 goes up into the exponent. So that means that x is equal to 25 plus 1. So the answer is equal to 26 then. Okay. Next one, you'll see x is in the base this time, but still the same idea. So the log base x of 64 is equal to 4. So that is going to be x is equal to, oops, sorry, I wrote it wrong. Let me go ahead and backtrack a little bit. 64 is equal to x to the 4th power. So 64 is equal to x to the 4th power. Since this is not something I'm not too familiar with, let's go ahead and take it step by step. We want to solve for x all by itself. So maybe what we can do is take the square root of both sides first, just to kind of, take little baby steps. So x squared is equal to 8. And then so x, if I take the square root one more time, is going to be equal to the square root of 8, which we can write as 2 root 2 if you want. Now, technically, there should be a plus or minus in this case, but the thing is we cannot take the log of a negative number. When you plug this back in there, right? Remember, another way of saying this is log of 64 divided by the log of 2 root 2. And I can't have the log of negative 2 root 2, so that means that that is going to be an extraneous solution. So the only solution I'm going to accept is going to be 2 root 2 or root 8 then. Okay, so I'm going to go ahead and box this and then box this over here. Okay. Keep going. Let's go to the next one right here. Log of base x 100 negative is equal to 10. And right there immediately, this should yield no solution because you cannot take the log of a negative number as we just said. So anytime you see a negative with logarithm, you have to think to yourself, hey, there's something fishy about this. So it might be the case where we just can't solve for it, or maybe it's just some sort of weird, unique answer. Okay. All right, finishing it up over here, 625 is equal to 5 to the x power. This right here we can solve for by getting a common base, right? So the 5 right here is our base. 625, I see that as 5 to the 4th. So that means that now that we have a common base, we can just compare the exponents. So x is equal to 4 in this case. And finally, for the last one, 7 is equal to 1 to the x power. And when I write it in this form, you'll notice that this is impossible to solve because 1 to any power is always going to be equal to 1 as a result. So therefore, this is also going to be impossible. And in addition, taking this right here and writing it out, you'll see why this is also impossible. Log of 7 divided by the log of 1, according to our definition, is equal to x. Log of 1 right here, that's equal to 0 because that's saying 10 to what power is equal to 1. So we can't divide by 0, so therefore it's not solvable then. All right, thank you so much for watching, and I'll see you guys next time then. Okay, goodbye.